Is my screen visible?
Yes, ma'am.
Yeah, okay. Thank you. Okay. So in the previous class, we talked about linear regression, how it is. Okay, and then we even discussed about how we are fitting a model for say a line equation in case of a simple linear regression, and then our aim is to minimize the sum of squared errors. So I think that much is clear. So we did a problem also where we had only one attribute and then one output variable, and we tried to build the relationship or the line, and then uh, based on that we are able to predict when a new instance is given. So I think that much is done. Okay, this also we talked about. There are different models here, out of which we understand that the model that is y is equal to 6.47 plus 0.62 into x, that model is more close or more correct, because it is actually covering most of the data points. So the error, the sum of errors would be, squared errors would be less. So that would be the best fitting model, and on the right hand side they have drawn that model alone separately, where we can see that the error, if you notice the distance here is minimal. Most of the points are very close to the expected point. So what we do is we try to predict, like say for example at 700, the prediction would be what is there on the line. So whatever value we get on the line for this particular x is our predicted value, and actual values here. So that distance is what we are telling as error. So like this for all points we would calculate and then sum it. So that is our, that should be minimal for a best model. So that is what we are going to do in our regression. Okay. So again, we are continuing with the same regression. So see here and there, you might see a little change in the notation. Somewhere people might use W0, W1, W2, etc. Where it is called weights. The same thing, it is theta naught, theta 1, etc. I am putting both because in different books you may see in different ways. So let you be comfortable with both. It is exactly the same. So you are notating using theta, or it might be using W. Okay, it is just the weights associated with our attributes. Okay, so here if you see, actually we might have multiple attributes, isn't it? Previous example when we did, we considered only the recording is started, right? Yeah, I think it is, yes. Okay. Previously when we did the example, we just considered one input variable or the attribute to be one. But of course, in our real data set, we would have like say d attributes or something. So for each, you will have a weight or a parameter called theta associated with it when you construct your model. Okay. So theta naught is the first one. Okay. Theta naught plus, then for each attribute, we'll have a weight. Okay, so and see if you can see the figure. Okay, the red dotted line, what you see is our line what we have fit. Okay, and then on that points are our predicted y, and actual y are these blue dots. So the distance, they are showing it as a black line, if you can see. So that is the distance. So if you square it and add it, that is your sum of squared errors. Okay, so our aim is to minimize it. Okay, so this is why suddenly h theta of x. Can one of you say me what is this h theta of x? What is h theta? H is our hypothesis. You remember long back we mentioned about hypothesis. It is nothing but our model. Okay. So h theta of x means our model. We have, I am audible, right?
Yes, ma'am.
Yeah. Okay, thank you. So our model, given an input, the model predicts something, isn't it? That is our h theta of x. So if you are not comfortable with h theta of x, understand that that is our predicted y. Okay, so predicted yi minus actual yi, the whole square, like this for all I to 1 to n, and then sum it. Okay, so we are not we are squaring it, so there is no significance for the minus and plus, because the difference, the magnitude is what we consider. Otherwise what happens is, you may have some minus values, you may have some plus values, and then it might get cancelled. Okay, so that is not our interest. Our magnitude, the difference, in magnitude, how much different it is, that is our interest. So that is why we are squaring it, so there is no issue of magnitude, and then we are dividing it by 2n. Okay, so now our aim is to, so if you can see in those figures, so one is a plane, one is an equation of a straight line, whatever it is, these red lines are the errors, and the blue dots are our point. In the first figure, the red dots are our points, actual points, and the predicted points are on the plane, and then that errors, that is the difference, is shown as a black line in the right side. So we are trying to minimize that. That is our intention. So now, so it is like we are trying to minimize the cost function or the error. Okay, error, sum of squared error is our cost function. Okay, so now what is cost function? Let us see what is that. So j theta is our cost function. So what is that? We previously mentioned. So that is h theta, sum of squared errors. That is what it is. So h theta of xi is your predicted y and actual y for each I equal to 1 to n. Okay. So each term you will square it and add it, and the whole term divided by 2n, where n is the number of samples. Okay, so that is our it is typically our sum of squared errors. So that is our cost function. Okay, now let us see what it is actually. Okay, let us assume there is some model, there is some sample data, and assume that theta naught is 0. Okay, we are not considering about theta naught, or assume that theta naught equal to 0. Okay, so we have, how would our relationship be? Actually, it should be y is equal to theta naught plus theta 1x, isn't it? Now, theta naught, I am saying, assume it to be 0. So, it would be theta 1x. So, your h theta of x or your prediction of y would be theta 1x. Okay. Is that fine? Is that much fine? Any confusion in that? H theta of x means the model. Okay, that is your predicted y or your model. So that is usually it is theta naught plus theta 1 x1 plus theta 2 x2 and so on. Assume that we have only one attribute to be considered as of now. So it is only theta naught plus theta 1x. Okay, in that we are saying, assume, let us say, just for example, we are saying theta naught is 0. Now, how would be your y? It should be h theta of x, or your predicted y would be theta 1x, because we don't have a theta naught. Okay, so theta 1x is our model now. Okay, so now assume that, okay, what is this left side figure? Can you see? Theta 1 is equal to 1. Okay, initially you are taking theta 1 equal to 1. So what is our y or h theta of x? Let us not say y, because your actual y is mentioned usually as y. So that is your y, and predicted y is your h theta of x. Okay, like you write usually f of x, isn't it? It's the same meaning, but we tell h theta of x because h is like a hypothesis, so it is the model. Okay, so h theta of x. Okay, now our h theta of x is y equal to x, that form, isn't it? H theta of x is x, because theta 1 equal to, it was actually theta 1 x, theta 1 is 1, so it becomes x. So how y equal to x line, the equation of y equal to x, that is this black line what is drawn. Okay, the red, can you see? I'll just show with the pointer. So these things, can you see the red lines here? Are you able to see? That is your actual, yeah. So that is your actual points. Okay, actual y. So this is your actual y's. Okay, and your predicted y or your model is your black line. Okay. So do you have any errors here in this example? Or can you tell me what are the errors for each point? What is the error for the first x equal to 1? Is there any error, or what is
No,
the
ma'am.
error? There is no error, isn't it? It is exactly coinciding. So in the sense, your actual y and your predicted y are the same. Okay, same as the next point, your actual y and the predicted y is same. Here also. So there is no sum of squared errors. So your error is 0. So can we say j theta is 0 in this case? J theta is our sum of squared errors. This formula, the first one what is written there. Now here anyway we got each term as 0. So can we write j theta is equal to 0? It is 0 plus 0 plus 0. Can we say it is 0?
Yes, ma'am. We can say.
Yes. Yeah. So that is what is shown in the right side. Okay. So when we took theta 1 equal to 1, okay. So that is this. Okay. Here what are we plotting? Previously we were plotting x across y, x and y. Now we are plotting theta 1 and j of theta 1. Okay. Now theta 1 is as in the example we took it as 1. Okay. And when we calculated the j theta, we got it as 0. Okay. So when theta 1 that is 1, we got the point or your j theta as 0. That is why it is the blue dot is your j theta 1. Okay, so at theta 1 equal to 1, we got our cost function to be 0. Okay, so now let us see the next value. So now first see the left side. Okay, so we are taking previously we took theta 1 equal to 1. Now let us take theta 1 equal to 0.5. Okay, now what happens? We have to again calculate. So what is our predicted points? Can you tell me what are these points? Actual points are 1, 2, 3. Previously we took it's the same point. So the points are 1, 2, 3. Actual y are 1, 2, 3. Now can you tell me what is the predicted points? You know that now
Ma'am,
theta 1 equal to 0.5. Yeah, correct. Tell me. Tell me, somebody said actually. Yeah, please repeat.
I mean, getting the 0.5.
Point, yeah. So, yeah, 0.5.
1.5
Yes.
into.
Is it 1.5 and 2 or 1 and 1.5? Because our points are 1, 2, 3.
The first point is 0.5, ma'am. Second one is 1.
Yes.
And third is 1.5. Yeah,
Yes,
0.5
yes.
difference.
Yes, 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 correct. So your equation of your line becomes y equal to or h theta of x equal to 0.5x. So whatever input you give for x, it will be 0.5 into that. So initially our x is 1. So our particular point at this line would be 0.5 into 1, which is 0.5. Now next point is 2. So x is 2. So of course your predicted y, your h theta would be when you multiply it into 0.5, of course it would become 1. Same way when you do it for 3, it would be 1.5. So these points are, this is 0.5, this is 1 and this is 1.5. Okay, this is normal mathematics what you do for equation of a straight line. Okay, usually when you substitute. So that is your predicted points and your actual points are here. Okay, which is 1, 2 and 3. So what would be the error? Can you calculate like this? It is 1 by 2 into 3 according to the formula. There are 3 instances. So 1 by 2 into 3. First point predicted was, you can see below, okay. Predicted was 0.5, actual was 1. So the difference square. The second point predicted was 1, actual was 2, the difference square. Then the third, it was 1.5, but it was actually 3. So that difference square. So this approximately it is 0.58. Okay. Did you understand how we are calculating this error? J theta. See, if any confusion is there, you have to ask me now. Is it clear?
Yes, ma'am.
Ma'am, in the J theta, is
Yes.
there any square root, ma'am? Like I remember studying, if we do the square means we have to take the square root also, like mean square
No.
error.
Okay, this here what we are considering is just sum of squared errors. When you say root mean square and all, there we will take. So here, as of now, we are not actually, if you can see in your models, like you have various kinds of squared errors also result, I mean, as a result, like if you have certain models in Python or say some applications like Veka, you will see different errors. So that is not I am talking about. In this particular, as of now, we are just considering just sum of squared errors. We are not taking any root here. Is that fine?
Yes, ma'am.
Ah,
Ma'am,
yes, somebody else.
what's that
Yeah.
divided by 2n for, ma'am? Like divided by 2n.
Yeah, that is actually because these many terms are there, no? So it's kind of normalizing. N terms or n, what is that? N points or n instances we are considering, isn't it? So we are dividing it by n.
But
Kind
the
of normalized.
2 is not required, no, ma'am. Like,
No, 2 is required. That is because exactly I am not saying we have both the terms, no? So it is, so the formula is not just like that given. So this is actually derived based on some certain things. So there is a reason for 2 also. 2 is required.
okay, yes, ma'am.
Okay, so it is not just n. And we sum of squared errors, of course, if you simply see the difference, I mean, sum of squared errors, the term, it is just this part. But then we need to divide it with n. Now, just n is sufficient? No. Actually, 2n is what we follow. I'll just see why 2 is required, but it is required. Okay, why not n? Why 2 is, n is for normalizing this value because we have n terms. But then why 2 also is required? I'll just see enter. It should be because both we are squaring it and we have both. But anyways, I'll just see and say you why this 2 is also required. Okay. So is that fine how we calculate our j theta? Any other questions if you have? Is it clear how we are calculating j theta? So now, so let us move on. So we now for theta 1 equal to 0.5. So initially theta 1 was 1. Okay. Our j theta was 0. Now our theta 1 is 0.5. Our j theta became something approximately 0.5. Okay. So that is why it is plotted like this. Now let us see for another value. Okay, so here theta 1 is equal to 0. Okay, so what happens now? So when theta 1 is equal to 0, what would be the line? Y equal to x line, isn't it? So the x line is here. So see, if you can see, differentiate, there is a dark black line here. So this is our line. This is our model, which is our h theta of x. This is our actual point. So now if you can see, there is distance like this. This is an error. This much is the error here. Sorry, it's not a straight line. This much is the error. So this distance is our errors now. Okay. So how will we calculate? So we will calculate it as 1 by 2 and into 1 minus, what is this? 0 the whole square. 2 plus 2 minus 0 the whole square plus 3 minus 0 the whole square. Isn't it? That's how we will calculate it. So what is that? It is approximately equal to 2.33. Okay. So like this, if you still now increase and see, it will be like this. Our j theta is almost like a concave function. Okay. So what is our aim? Our aim is to actually minimize our j theta, the cost function, isn't it? So since it is like a concave function, okay, so we know that we need to find a minimum. Okay, so we can find the minimum based on certain approach. So we are just telling what we are saying is our j theta goes like this. When we vary our theta, our j theta is like this. Okay, and our aim is finally to minimize our theta. Okay, so not always 0. We might get something similar, very close to 0 or something like that. Okay, so let us see what it is. Okay, so we are just telling, so initial value of theta would be chosen, and then we come to us so based on a certain procedure, we will come back to a place of the theta, value of theta, where we get a minimal value of j theta. So for that, we have something called gradient descent approach. Okay. So this is the actual formula for it. The theta j, that is our weight. Okay, it is modified as theta j minus alpha into derivative of j theta. Okay, so not so important, derivation and all we will not ask. I'm just showing it. Okay, I think some of you would be more good at it than me. Anyway, let us just just brush through, I mean just go through that, what is happening. Okay, we need to just apply and understand how we'll modify our weights. Okay, our theta initially we'll choose something and then we'll keep for each iteration we'll keep modifying the value. So that's what we'll do. Okay, and alpha is the learning rate. Okay. Okay, so now let us see. So we know that j theta is, previously we have written it is 1 by 2 and sigma, it's theta of x minus yi, isn't it, the whole square. So we know this. So we're just talking about this particular term. Okay, this term, I mean not even the alpha, after that just the derivative of j theta. So now let us see what is that. So it is 1 by 2n into this, the whole square. So what is h theta of x? Can we write it as theta k sk, sorry, sigma theta k xk? Can we write like that for h theta? Because what is h theta? It can be theta naught plus theta 1 x1 plus theta 2 x2 plus etc. Isn't it? So that is what is written, theta k xk. Assume that x naught is 1. Okay, there is no x naught. Our instances attributes start from x1. So x naught we are assuming it to be 1 because we have a theta naught. Okay, so it is just theta k xk. Now, if you do the derivation of this, so it is like 1 by 2n into whatever term this is. So we are trying to find the derivative of this. So it is 2 into this particular term's derivative, isn't it? So that's what is written. 2, so that 2 and 2 got cancelled. Okay, and then it becomes sigma of this into the derivative of this particular term. Okay, now just a second. So now when you try to say derivate this, what happens? So we have only one term which is actually having something. So how do we find the derivatives? It should be dependent on theta j, then only there is some derivative, isn't it? So if you try to evaluate, so y is not dependent, I mean y does not have something which is on, y is our actual y, not predicted one. This y is our actual y. So it is not dependent on theta j, so it's gone. Now we have first term. In that, if you expand, you can see that it is theta naught plus theta 1 x1 plus theta 2 x2 and so on. So when we say derivative with respect to theta j, only that term, so theta j xk would be there, isn't it? So only theta j's coefficient, that is xj, would be there when you derivate this. So full this term when you derivate, you get only xj of I. Okay, so this is our final whatever we derivate and bring it up. Okay, so now let us see. So it's okay if you are not so comfortable in that. Let us move on to first, and there is some iteration, like always we cannot say that your error would be 0, etc. There will be some, we will say that each time, what are you going to do? Choose initial values for theta, keep updating theta, and it reaches a minimum. Or we say that the change between the new and old theta is some less than some value. So till then we'll be keep on iterating, something of that sort. So that is the convergence criteria. So let us see one example. So before that, it is just what is that? How are we writing? So here, since I am taking an example from a textbook, there instead of theta you will see w. That is the only difference. So theta, instead of theta naught, we will write it as w of 0 plus w of 1 x1 plus w of 2 x2 and so on. Okay, now we are starting with some initial random weights. Okay, and then each iteration we are keeping on updating, and then there is some convergence, that is that change or difference in the weights should be less than some epsilon value. Okay, so then we converge. Okay, so there is a problem. Okay, so size of the flat, floor, broadband rate, and rental price is given. So this is how we are going to do the problem. Okay, just a second. Okay, it's okay. My mouse. Yeah. So these are our prediction variable or your output variable or your response variable y is rental price. These are your input variables. Okay, so we have 3. So our equation should be, or our model should be, h theta of x is equal to. So when we say we have our model as say w naught plus w1 x1 plus w2 x2 plus w3 x3. That is our prediction of y. Okay, so this is finally some prediction what we have to make. So leave it. First we'll start with how we'll update the weights. Okay, can you see this top part also? You can see the learning rate. No, there is a learning rate. Okay, and some issue. Just a, my mouse is not working properly. Are you able to see the initial weights and the learning rate? One of you just unmute and say me. First line.
Yes, ma'am. Yes, ma'am.
Yeah, okay, okay. So the initial weight, we can see that W0, W1, W2, W3, they are the initial weights. And the learning rate alpha, initial formula, if you had seen, theta j is equal to theta j minus alpha into derivative of j theta. That's how it was. So usually learning rate will be very, very small. Okay. So learning rate is also given, the initial alpha. This is alpha, learning rate is alpha. Okay, now the weights are also given. Now we know the input we had. Okay, so we had 3 attributes and we had the price, actual y. That is your this what we see is our actual y. Okay, so can we predict the y now? We have all the inputs, isn't it? That is, we have all the weights. So our model would be y w0 plus w1 x1 for the first instance, w1 into the first x, okay, plus w2 into the second parameter plus w3 into the third parameter. If you calculate, you will get predicted value as 93.26. Okay, this is our predicted value for y. You know the actual value of y. So can we know the difference? That is our error. Okay, we are calculating the squared error also. Let it be. Now what are we supposed to do is, here is the main step. Okay, how we find here that parameter what we wrote finally after deriving that derivating that j theta, we wrote a term, no? So that here we say it as error delta. Okay, so how we calculate is, now we have found the predicted y error. Did you understand how you will find the predicted y and the error? This is how we have done previously also. Okay, here we know the w1, w2, etc. So we are just substituting and finding according to this weights, how will we calculate the y. Okay, and then the difference would be your error. Okay, and just square it. Now w0 is, you remember we told x1, x0 is 1. So we are just writing it. Okay, w0, we are not modifying anything. We'll just write the error itself. Okay, or we can say into 1. Now w1 would be error into x1. Okay, so what is the first value of x1? I mean, in the sense, the first instance, the first parameter, what is the value? So that into 226. So if you go back, first x1 is what? 500. Okay, our first x1 is 500. Okay, in the first instance x1 is 500, and in the first instance our error was 226. So 226 into 500 is this particular value. Okay, it's not 226, it is 226.74 into 500. Okay, so like this, so you got it as this value. Similarly, you will get the second parameter. So error into this 4. Okay, similarly error into the next value. So that is our W1, W2, W3. Now what you would do, this is our the sum. You are finding sum of each of these terms. This is our error delta. Okay, now we have a formula. So this is a just calculation of error delta, that is W1. Just a second. Yeah, error delta, that is W1, we will write as prediction error into X of 1. That's what I told now. Same way W2, how we find prediction error into X2. Okay, so like that we'll find. Okay, and then finally we'll sum it. Like similarly for W3 also. Now updated weight. Okay, so formula is not put here, so I'll just show it in the so see, if you can see here W of 0, okay, what is current now, like new W of 0 is currently what is our W of 0, that is point minus 0.146, isn't it? That plus what is our learning rate, it is 0.00, so many zeros into 2, I mean 0.000 into 2 into what is 31, our new sum, what we got, error delta sum we got, isn't it, for W0. That is our this term. Okay, so this when you do, you get your new value of W of 0. Similarly, how will you calculate W1? Current W1, which is this 0.185, okay, plus the learning rate, which is this value, into this particular value, error delta of D comma W1. Similarly for all these, so that is how you will update your values for W0, W1, W2, W3. Is that fine? Shall we do for one, maybe one iteration, or which one would you like to do? Just for a trial. Maybe I think we can just try this part alone. Shall we just try this? Can somebody take a volunteer yourself? Somebody should find whether this updated value of weight for each, like so W0, W1, W2, etc. are just when you calculate this, are you getting this? Can one of you just try? Who will try? No one will volunteer. I should only call, or somebody would volunteer. What is happening? Is somebody here, or all went for placements? I can see 75. Priyadarshan, can you try one?
Yes, ma'am, I'll try.
Yeah, W0 you try. Who can try W1? So what you have to say, try is this formula you should try applying on this, okay? Current W of 0 plus the learning rate is given here into this particular value. So you will get this. Okay, that's what you're going to check. Same way somebody else. Eknath, are you here? Yeah, can you try for W1? I'll just tell you what is, how do you find W1? So previous value of W1 is here, 0.185. Okay, the current value. Okay, now our formula is like this. W1 is equal to current W of 1, which is 0.185, plus learning rate. What is learning rate? That 0.00002. Okay, into this 2400. I mean, it's not 2400, it's a big value. So I think this particular value, the sum of error delta of W1, D comma W1, this value, when you do that, are you getting this? You should tell me. Okay. Same way, can you try that? Eknath? I mean, what is your name? Eknath. Yeah, Ekant. Can you try?
Yes, ma'am.
Okay, just try. It is there on the screen. You can just try for W1. Same way, who will try for W2? Gayatri, are you here?
Yes, ma'am.
Can you try for W2?
Okay.
W3, who will try? Priya, are you there?
Yes, ma'am.
Yeah, can you try for W3?
Yes, ma'am.
Yeah, just you are checking all the values are here. You're able to see the screen still, right? So all the values are here. You are saying this formula. This is what you're going to try. This. So that is W of, so if it is W2 for you, current W of 2, I mean the next value of W2 would be current W of 2 plus the learning rate into this particular value, that is 27,888 if it is W2. If it is W3, it is 88,727. Okay. Just try and say me whether you're getting this particular values itself.
Ma'am,
Yes,
W
ma'am. For
naught is
W1, I am getting, ma'am.
You're getting 0.233. Okay, W naught.
it's minus 0.145936.
Yeah,
It is
correct. So it is approximated as minus 0.146. In our data also it is minus 0.146. Approximated to minus. Actually, it is not having a change, isn't it? Almost same. So either we round it off to 3 places or maybe 4 places and then continue. It is fine. That is fine. It is correct. What about the next W1? You are getting 0.233. Somebody, I think, said about W1, no?
Yes, ma'am. I only told.
You got.
Yes, ma'am.
Yeah.
Same.
Yeah. Okay. So W2.
I'm getting minus 0.0439.
Minus 0.043. Correct, no? 0.0439. Okay. It can be 0.44 or 0.439 itself. That's okay. What about W3? So all the terms they are approximating to 2 places and the weights we are taking it to 3 places. It's okay. 3 or 4 places you can take, not an issue. What about W3? Did you get, Priya?
Um, I was asked W3, ma'am. I thought it's W2, and then
It's okay. But you understood now how you are calculating. So this is how you are going to update your weights. Okay. So now again one more iteration. So in your test, it might be like 2 iterations. Okay, we'll give. Because actually if in this example, if you see, it won't converge now. Okay, now we don't know what is the difference. Okay, the difference should be minimal, some threshold. I have not mentioned it here, I forgot. So even if it is mentioned, I think it actually converged after some 50 to 100 iterations. So that is not possible for us. Only when you do it using computer, it's feasible. But understand that this is how you keep on updating your theta. Okay, and once we have a difference which is like very minimal, we stop. Okay, so did you understand? You have any doubt in the steps, the problem solving also?
ma'am.
Maybe, yeah.
What is the W naught in the right side, ma'am? W naught, W1, which we have calculated.
That is our, now we were discussing about derivative of j theta, no? So that term is actually our error delta, which is squared error. If you remember, it was something into xi, isn't it? Some term into
Yes, ma'am.
xi. So that is this. So our error is calculated. Okay, that is our predicted y minus actual y, okay, into our particular xi. So that is what we are doing in each term. So it is just, though we write, so if you can see, I'll just make it as a point, just a second. So if you see this W naught and all, this is not W naught, it is actually, we are trying to, we can say for error delta, we are calculating these terms. W naught, W1 is only this, what now you calculated. So this term, you can just maybe write delta W naught, something like that. If you want, you can write. So the terminology, if you see this W naught, we cannot use here. In the process of calculating W naught, this is what is calculated. So this is actually D comma W naught. When you multiply your D, which is your instance, your X value, into your error value. Okay, so that is your this particular term. So we can say this is error delta of D comma W0, error delta of D comma W1, error delta of D comma W2, and so on. And finally you submit. That is what is used for your final updation of weights. These are not weights. Don't think like that. If you're getting confused, don't use this at all. Okay, you can directly use error delta D comma W0 like that itself. Is that fine?
Yes, ma'am.
So that is not your weights. That is your error delta calculation. That's it. Is that fine? Any step is not clear? You want me to repeat or something? Any steps?
Ma'am,
Yeah.
for the W3 calculation, like we will be just doing 0.121 plus this alpha into
Yeah. The next iteration you're talking, or the previous? Actually, current what I asked some of you to calculate was the iteration 1. So the previous value of W3 is 0.119, if you can see here.
yes,
Yeah.
yes, ma'am. Okay.
Yeah, so it will be, how you will write, update the W3 is 0.119 plus the learning rate, which is 0.00002 into this value. This value, error delta of W comma 3. Sorry, error delta of D comma W3. Is that fine?
Yes, ma'am. It's thank you.
So it is 0.119 plus 0.00002 into 88,727. That is your updated value of W3. We'll do maybe one question, then you will be more clear. Actually, you can do one thing. You can try on your own this without seeing this, and then just manually verify whether it is correct. Because otherwise you will not be able to solve problems when you get some. Iteration 2, can you all try and come? I'm not sharing this slide. Okay, I'll maybe just like previous time homework I gave, no, like that I'll give just this and the initial weights and the learning rate. Okay, and I'm sorry, not the initial weights, the new weights. I'll give the new weights after iteration 1, and I will give the learning rate. You try to do the iteration 2, and then let us see whether you all are able to come back. Okay, if there is some difficulty, then we'll discuss. Then I think it will be more sensible. So iteration 2 alone you need to do. I'll share the screen accordingly. I mean, I'll send you the homework as a PDF. Okay. Is that fine? You understood how your theta gets updated? So there is one more thing. I'll just tell this and stop. I think one more, it's already late. So learning rate, you usually choose based on something like, say, if it is not given, you can choose like, say, 0.00001 to 10, something of that sort. And initial weights, actually, there is no specific rule that you have to choose in particular range, but they have, from the different experiments conducted, they have identified that usually when it is between 0.2 to minus 0.2 to 0.2, reasonably good convergence you get. Okay, So if nothing is given to you, you can choose something like this and then start. Okay. So in our example previously discussed, after 100 iterations, it has converged, and then the final value was this. Okay. And sum of error, squared errors for the final model was this. So let us see the rest in the next class. Is that fine? Anybody wants to ask anything? Otherwise, we'll just end the class.